That brings us to today's session, which is part of a month-long series hosted by Gwyn, a cloud advocate here at Microsoft. She'll be taking us on a journey through Azure, focusing on topics that are part of Microsoft's 30-Day to Learn It challenge. If you are not familiar with that, we will be dropping the link into the chat momentarily. Her guest today is Mark Durker. I can't say it right. He's going to have to correct me later. So sorry about that. A lead Azure consultant at Spirit. Our session will be covering orchestrating long-running workflows with durable functions. And this session will run for approximately 60 minutes with time for questions throughout. If you have not done so already, we just ask that you check into this session that was up on the screen earlier. I will put it up on the screen again now. Let me just go over there and do that. If you check in, you'll get some event resources, a Learn module that Gwyn will be working off of, partially that relates to the 30-day challenge, and then just some also helpful links as well. At this time, I'd like to bring our group up. Here we go. Hey, Gwyn. Hey, Mark.
Hi, everyone. How are you doing?
Welcome, welcome.
We got quite the group watching already. Hello, everyone. Feel free to, let us know where you're from, where you're checking in from in the chat. We love getting messages and sort of hanging out and feeling like this is casual. We're learning, but, we're hanging out, right? Mark, how are you doing?
I'm doing pretty well. Yeah, I'm also pretty busy at home because I'm doing a large reconstruction of my living room and kitchen. So it's a bit hectic, but I was looking forward to our session today. So thanks for inviting me for this.
Of course, when I said, I was thinking of, planning out this series, and I wanted to focus on developer technologies for September, and I knew functions was going to come in, and if function comes in, I know I have to call you. I know I had to message you like, Mark, we got to do something, because you are probably one of the most knowledgeable people when it comes to Azure Functions that I know, and hey, I know a bunch of people, so that should say something, right? And we worked on a couple of things. I'm a big fan of Azure Functions University, which is a GitHub repo that you built, sort of like an open source, like lessons on Azure Functions.
Yeah, exactly.
Which it's probably my favorite cloud service of all time. We sort of share a love for it. So I knew we had to come together and do a little something. Now, today we're doing probably one of your favorite things, which is durable functions. Yes. I know you do a lot of work with it. In terms of solutions that you build with functions, how much time do you think, or what percentage do you think you actually use durable functions for that?
I think 100%.
Wow.
For the last 2 years, I've been only involved in serverless, and all of them were using durable functions as well.
Let me ask you this, because you probably know better than I. In terms of other solutions out there that can accomplish what durable functions accomplishes, do you know anything like any other service that can do something similar?
Well, within Azure, there's logic apps, for instance. So that's more you build your workflow visually, but to do it really from code and to be able to also retry all kinds of things and make sure your workflow is resilient. Yeah, I don't think there's another similar service.
I would agree. I think that's what makes functions sort of stand out, like this durable functions extension. And we're going to dive into it. It's funny that you touch into logic apps, because I was going to ask, logic apps allows us to, sort of build these serverless workflows. Do you ever find yourself using like logic apps instead of durable, or maybe side by side or together in solutions, things like that?
Myself, not so much, but that's also probably because I have this developer background, so I probably am easier to choose for a full source code solution than maybe something graphical. But sometimes I do tell my customers, like, hey, you could do either in durable functions or logic apps or something Power App related. So it's not that I'm always just only advocating for durable functions. You have to make sure that you choose the tools and the products that also fit in your development team, and that you have the skills to work with the tools. But yeah, personally, I've been doing only durable functions work lately.
You mentioned that. So last question before we dive into your demo, because I know you have a lot to show us. I know when I messaged you, you're like, I have the perfect thing. I'm literally building this thing in production. And I was like, if we could water it down, a little bit just for those purposes. And you went ahead and built something that's amazing. And I can't wait to share. But you mentioned that you've been working with sort of serverless for the past 2 years. It's just sort of been your life. You're like, you're stacked serverless. I'm curious to see like sort of what pros and cons you've encountered in your time working with this technology.
Well, the immediate pros is that it's really easy to get up and running it very quickly. So it's very easy to just prototype something and even push something to production, just like in a couple of days. So that's really what I like about it. So that's why I also like to do all kinds of prototyping with it and stuff like that. So it's perfect for that. When it's not the best fit, you have to think of maybe when some things are really memory intensive, or you need to do lots of processing of images of videos in parallel or things like that. Then something like Azure Batch would be more appropriate, especially for the consumption model, because then you have, let's say, lightweight environments with limited memory and CPU available. So it really depends a bit on the workload and on the requirements around it. If Azure Functions is a good fit, and within Azure Function you still have these different SKUs. So instead of consumption, you could also go for premium, full app server. So there's lots of variations still.
Very cool. Yeah, I would agree that I think serverless is turning into something that more and more like can cover scenarios. Like you can answer a lot of solutions, but like, oh, let's give serverless a go with this, and like years ago, right? So, that's great. I want to say hi. Hi, it looks like Rishab's in the chat. David from the UK is in the chat. Welcome everyone. Feel free to like pop in those messages. I love seeing them. Nice. So why don't we bring up your screen, Mark, and dive into the demo. I know you mentioned you wanted to like run it at the beginning, so we have an idea we're working with.
Yes. Let me need first start with just two diagrams, so we know what we're talking about.
Love diagrams.
Context. Again, always hand-drawn. So it's about this fraud detection function app that we're building. So what's coming in are financial transactions. So there's an amount in there and a currency and so some bank account information, things like that. And we want to send them over to a service that analyzes that transaction. Because we're not doing that ourselves, there are lots of third-party services which can do that. But before we can send it to that third-party analysis service, we need to enrich that financial transaction with some customer data. Because usually a transaction is a very small object and there's not a lot in there. So we also make a call to another service, or customer data service, to get some more information, so like names and countries and addresses and things like that. And finally, at the end, we get a response back from this fraud analysis service. Then, in case the server thinks it's a fraudulent transaction, then we want to store it in Cosmos DB. So that's the high level context. So it's talking to different APIs and storing it into Cosmos.
Okay.
And I think that the most important thing about this analysis service is it won't give the result immediately. So, for instance, this customer data service, we make a call with our bank account, and a customer object comes back immediately. But with this fraud analysis service, we just get a 202 accepted response back, but we don't have the fraud result yet. So what the service does, it will, when the result is done, let's say after a minute or so, it will call back to a webhook, which is also in this function. So whatever is happening here, it needs to wait until this result is done. And then it will store the record in Cosmos.
Right, and this is where Durable sort of shines, when there's like steps that you have to take, and things might not be immediate, and you'll have to like wait for a response and things like that. So you'll sort of use Durable to orchestrate, and you'll have different activities and such. We'll dive into those deeper, but this is something that if you were to use like Azure Functions without Durable would be pretty tricky, if not if possible. What do you think?
Yeah, it is doable, but you have to create lots of more functions and also add more queues and things to it yourself.
To manage.
Functions really abstracts
responses
away a
to
lot of these
states.
things. Exactly. Yeah. So it's possible, but it's more development work and more infrastructure work for you as a developer to do.
And oftentimes, as developers, we like to reinvent the wheel. Personally, no. If I can
No.
leverage something that exists already, if I can
Yes.
just click something on and it works perfect, that's what I'm going to go do. But
Exactly.
sometimes there's a little bit of that culture of like, oh, I could just build my own serverless stack from scratch, right? Things like that,
Definitely
right?
pitfall a lot of people do, but please don't do that in India. Just spend 1 or 2 days looking around what's there in India and learn about it. Especially with these events from Microsoft Reactor, it's very valuable that these things are done to learn more about what's available, because it can save you weeks and months of development time. Definitely.
Exactly. All right, so you want to run the actual demo and we'll go from there. Wait, you have another diagram. I think you mentioned you have two.
Yeah, well, let me just make sure that we have the basics of durable functions. So let's do this one. So with durable function, there's a couple of new function types are introduced. So the first one is called the client function, and the responsibility of a client function is to start a new instance of the orchestrator function. And the orchestrator function is what we already talked about. That contains the logic, that the workflow, which other activities need to be scheduled and need to be called. So this contains some business logic. Okay, first call the customer data service, and then call the analysis service, and then wait, and then finally call the service that to store the Cosmos DB result. So that logic is in here, but this orchestrator service does not make the API calls itself to all the other third parties. So all of the heavy lifting is done in separate, very small activity functions. So there's an activity function to call to the customer API, an activity function to call to the fraud analysis API, and there's an activity function to call to Cosmos DB.
Okay. So could we summarize that? So the client function is what calls or like starts, or like how we can access the workflow. Then the orchestrator would be sort of the thing that's saying, all right, this activity, then this activity, and this activity. And then the activity functions are the ones that actually perform the actions.
Yeah, exactly. So this is the smallest unit of work, all these things. Yeah.
All right, cool. So, got it.
All right. Let's run it, and then we'll dive into the code.
I like these diagrams. You said you made these from scratch.
Yeah. I've got this small surface with a pen, and I just love drawing all these things. So
I'm very jealous because I can't draw anything at all. And you're quite the artist. I know you do a lot of pixel art. I know there was a little. I think you did like a Clippy and then an Azure Functions and a bunch of things like that. So it's quite creative.
I definitely like to combine my creative side with technical side. And that works pretty well with these things. So that's cool.
Yeah, love it.
All right. So the function app is building now. So it's not yet running. So most of it is all running locally. So the function app is running locally. Durable functions is also dependent on Azure storage, on a storage account. But we are emulating that storage account locally using Azurite. So we're not calling out to Azure for that. The final step was posting results to Cosmos DB, but Cosmos DB also has a local emulator, so I'm also using that. And it's a bit too slow because everything is still running. I have to stop it.
Or I always have errors. My last session I had like 3 errors. So we worked through them. I think that's like the best part of like live. It's like you never know what's gonna happen. So
yeah, exactly. But it's about the debugger, and I don't need the debugger. So let's see if it actually will start.
Okay.
So the function starts because it's an HTTP trigger that actually starts it. So our client function is triggered by an HTTP call, and I'm using the VS REST client, VS Code REST client, to make that call. So this is the route of my local function app, which I'm not sure if it's running. Now let me just try it, otherwise I need to start it again. No, it's not running. Okay, let me stop this and retry. Let's build it again. So as I was saying, most of it is running locally. The customer data service where I'm talking to more errors. Nice. Typical. So the customer data servers where I'm talking against, I'm actually just faking it. So that's also running locally. The thing that's not running locally, that is the fraud detection service. I'm not using a real fraud detection service. I'm actually
you're sort of like mimicking
I'm mimicking the I'm using something else which gives me back a response and to a webhook. So that will work out. Okay, so now it's building the function up again, and hopefully it's within the 60-second limit, so we can continue.
You mentioned the client function is an HTTP function, so is it fair to say it's very similar to your standard Azure functions with an HTTP trigger?
Yeah, definitely. The client function is just your regular function, so it could be HTTP triggered or Q triggered. That doesn't matter so much. You only add another attribute to indicate that this has some additional behavior, so it's part of durable functions.
And all the say triggers that are available to your normal Azure functions, you can use on these client type functions as well.
Yes, yeah, exactly. Yeah, you can also use input bindings,
Very
output
cool.
bindings, so that's fine. And okay, I have to increase the timeout a bit.
Okay, what do you got to set it to? Like 5.
So.
This is good. It's good debugging because oftentimes you would have to increase the timeout. I think what's the default? The 60 seconds?
I think 60 is indeed the default. Let me do this on another screen, but I'll need to change the settings to make sure we have a bit longer because since we're also streaming and
go ahead.
More busy, so
I'll talk to the chat. Can I bring up things onto the screen? Oh yes, I can. Is cloud not a niche anymore? Everyone's certified across multi-platforms. What is the new niche? Serverless. That's an interesting question. Is cloud not well, I don't think, was cloud ever a niche? I think we have sort of this perhaps a misunderstanding that cloud is sort of something magical. And remember, it's just a place where we can run our applications and infrastructure. And then within cloud computing, you have just like a bunch of stuff. Like you want to develop, you want to administrate, you want to architect, you want to secure. There's like a whole bunch of areas, but those areas existed prior to cloud as well, right? When you think of like on-prem infrastructure, all these things like networking and security and storage were a thing already. I wouldn't necessarily say cloud or even. I'm hesitant to say that serverless is a niche. I think it's very, very popular now. So if that provides somewhat of an answer for you. David tells us that we definitely love to make mistakes and computers love us. Well, the thing about computers is that they know that when you're doing a demo, it's like printers. Like when you're urgently needing to print something, they don't work. Yes. And computers are the same. Like when you urgently need to run something, the demo, it's like almost 100% chance like you're gonna encounter an error.
Indeed, yeah. So I've increased the time to allow it to start up. So I've doubled it. So we should be okay now.
All right. You were working on this. We just spoke about this maybe what was it, like Friday or something like that, and everything was smooth sailing. So of course,
yeah, always need to happen something, right? Didn't make the proper sacrifice for the demo gods and stuff like that. So
you know what? I had doing with a Blazor. I did a Blazor session. I forgot to include namespace, so it couldn't find like the proper class, so I couldn't get something to run it. And I was like, oh my goodness, how could it be such a silly mistake like that?
That's amazing. Yeah, exactly. yeah. It usually turns out to be something very, very silly indeed. Which takes you minutes and minutes to solve while doing a live stream.
I feel a lot of pressure because it's like people virtually watching you. Like, no, my goodness, I need to fix this right now. I promise I know what I'm doing.
Oh, and it still fails. What's happening? It's
still picking up that 60-second value though.
Yeah, exactly. It shouldn't need to do that. Because I've set it to 120 now. So okay, let's do it just one more time. Difficult. What I can show right now is maybe a bit more like a detailed overview of the functionality. What what
Right.
we're about to demo.
Yeah, let's step through that. Yeah, that's fine.
So this is a bit more technical then. I'm about to start this function app by providing a transaction to this fraud detection client. That will then start an orchestrator, and you don't really see the orchestrator in this picture because the orchestrator is like a logical grouping now of all the different activities that we're doing. So what we're seeing here is all the different activities. So the first activity it will call is the get customer activity that will call out to a customer data service. So that's the first thing that we're going to do. Once that has been done for both the debtor and the creditor, so it will call this activity twice. We'll create a new object that will be used for the analysis. So it's called an audit record. So we combine the transaction and the customer data into something new. Then we call that other activity to analyze this audit record. And yeah, that's asynchronous. So we get back an accepted response and we don't get back the fraud result yet. So then our orchestrator will wait. And if it will wait, we can also specify a maximum wait time. So that's pretty useful. So if it takes longer than that maximum wait time, then we just fall back to a default result. And we then check, okay, is this suspicious? And if it is, then we store it in Cosmos DB. If we do receive a response from the analysis service in our webhook, then we process that, we look at it, and again, we follow the same path. So this is a bit more in detail.
If we had to, say, manually provide that fraud result, that could also, like, it would be like sort of like human interaction. That would also be something that durable functions could handle.
So you could say this is some kind of approval workflow, because this fraud analysis service is actually kind of approving our transactions. So it could also be a manager that approves your holidays, for instance. Yeah, exactly.
Okay, looks like it ran now.
Exactly. So the function is up and running. That's good. We see two endpoints. Exactly. I'm going to call this endpoint now. Again, we switch back to this HTTP file. So I'm going to call this endpoint. I'm giving it a payload that resembles a transaction. I'm actually generating some random IDs for the ID itself, some bank account information and amounts. So let's call this, and well, it will roughly take about a minute, but at the end we should expect another document here in our local emulated Cosmos DB storage. Right. So let's make the request. All right. What's also important to realize, whenever you start an orchestration, in this case using an HTTP client, you get back a so-called check status response message. So you get back a 202 accepted, and that contains the ID of the orchestrator we have just started. And with that ID, you also get some additional links. And with these links, you can do some other things with the orchestrator. So we can actually check what is the status of this orchestrator, of this workflow. So when we click this link, I also have this link here. So let me check it right now. We can see that the orchestrator is still in running state. And if we scroll back here, we see that one of the last things it did, it actually called out to this analyze audit record activity. And so it has called out to this external service, and it's now processing, and we're waiting for that callback to come in. So our orchestrator is now just idle. It's just waiting. It's doing nothing. Okay. So after a couple of more seconds, then we will see some more activity here. And now we see that the store audit record activity has been called, which means it has stored it into Cosmos DB. So when we do another request to check what is the status now of our orchestrator, then we will see that the runtime status is completed. So that's a good sign. Okay. Other statuses could be failed. Maybe if there was an exception somewhere and the orchestrator is just broken, then it's failed. It could also be pending. Then it hasn't started execution yet. It's just waiting to be picked up. So let's refresh this, because there should be an initial document now. So the first document was a CB7 that was already there, but there should be an additional one now.
I like that you have everything set up inside of VS Code. Like, I need to do that because I'll use Postman, so like a different application aside. Then I'll have like the storage explorer or like a portal open instead of having it all. But I like this focused way of developing with functions. I'm gonna have to like copy your setup.
Yeah. I found this yesterday or the day before.
Wow,
And,
just in time.
so just in time, yeah. And I also found an extension that shows you the current activity of GitHub workflows, GitHub actions. You can also
No
have that.
way.
Yeah,
You gotta
yeah.
share
So,
that. You gotta share that with me.
yeah. That's this one, but I'll share the link later on.
Okay. Awesome.
We'll see that the audit record document, so that's a combination of the transaction that we posted, but also our customer information and the result of the analysis service. In this case, it's marked as true. So it's all there in Console Zubi. So our workflow has done its job. So that's pretty cool. Let's have a look in the code, I think.
Do you want to show? Well, might not be important, but I know you mentioned that you're mimicking the fraud detection analysis with just like some. I think you're using like a GitHub action
exactly.
or something like that.
Yeah, so it's a bit of a trick I'm doing because I really wanted to mimic the webhook behavior, yeah, because
like the waiting part, yeah.
A lot of online tools have this webhook functionality. So when something happens, it can trigger a webhook back. So I wanted to do that as real life as possible without an actual financial transaction analysis service.
Right.
And so what I then thought, okay, I'm gonna use GitHub Actions. So what I'm actually calling from an activity, we can show the code later, is that I'm calling out to GitHub to start this fraud detection workflow. And this workflow that is then just creating. Well, at first it's waiting because otherwise it's too quick. So it's first waiting, pretending to be busy. So that's why I named this step. And then it's actually calling out to back into my local function app, and by making just a using curl to do a post to an endpoint, and that endpoint is retrieved from a GitHub secret. So and you might be wondering, okay, but I'm calling from the public internet. I'm calling back to my local function app.
Yes, I was about to ask you that.
So what I've also done is I'm using ngrok to expose my local host using this URL. So I'm using this URL in combination with the function URL as a GitHub secret, and the GitHub workflow is using that URL to post back to my local application.
Very cool.
I'll do a write-up of this because it could be useful for some testing purposes.
I was about to say, this is something that even outside of this demo, I think would be quite useful. Like I can think of things that I could probably use something like this, just like mimicking. So oftentimes when we work with, I guess anything that you're developing or any solution that you're sort of working on, there's these different pieces that you might be working on and you might not be working, other people on teams might be working, right? So it's like, if you sort of abstracted this and made this more available to, like, for other things, I think it'd be fantastic, right?
Yeah, exactly. Yeah. No, I'll definitely do a write-up of this. Yeah, because the workflow is not very big. But one of the things that was required is I need to pass in an ID of the orchestrator. So I'm also using an input for that GitHub workflow, and that was something new for me. But that works very nicely. It's all
very cool
in the GitHub repo, so it's all available. So you can definitely have a look at that.
Yeah, do make sure that you check in people so you can get access to all this code and the write-up and things like that. I know Mark does a very good job at being quite detailed. Like yesterday I saw you were going through the repo and I was getting the notifications and things. I was like, wow, Mark's really putting in a lot of work for this.
I was updating it like crazy. Yeah, exactly.
Right. All right. Okay, so we want to step through the code now and sort of get into the nitty-gritty details.
Exactly. Yeah, I think it's good that we see what does it look like, what does a client function look like, what does an orchestrating function look like, and those kind of things. So I usually have always the same structure of my function apps. So since these function apps have separate named functions, I usually have a folder for my activity functions. I have a folder for client function, a folder for orchestrator functions. Then also usually a folder for any models I use. So this structure is what I find useful to work with. So when I look in the clients folder, I have two client functions. So this is the main one. So this is what I've just triggered. So it's an HTTP trigger function. We do a post, but what's special to this, well, special is that we also use this Drupal client attribute. And when we use that, then Azure Functions will inject a Drupal client and then use the Drupal client to do all kinds of things with orchestrators.
So this is the first function. This is where, like, if you want to start the whole thing, you have to call this specific one. So when you ran the demo like previously, and that first call that you made was to this function.
Exactly. Yeah, right. So, and I've posted it with a transaction. So I'm extracting the transaction from the request content. So that's the first step. And then the second step is actually using that Drupal client interface. And I'm using the method start new async. And that instructs Drupal functions to create a new instance of this orchestrator. And yeah, you'll notice that with Drupal function, everything is done by name. So all of the scheduling and calling out to activities, it's all done by name. So what I usually do is I just have one function per class file, and then I use name of, and then I use the name of the class. So I can have some kind of strongly typed reference to these orchestrators.
Okay.
So here we start an orchestrator, and we provided this input. So the second argument of the start new async is the transaction itself. Then we immediately return this HTTP call with this check status response, and that's what we've seen earlier. That gives us back the orchestrator ID and some URLs to check the status or to terminate the orchestrator completely.
Okay.
Let's have a look at the orchestrator then.
Hold on. Before we move on, I have a couple of questions in this one. So I see our client function is, actually, obviously it kicks off the whole thing, and then it calls the orchestrator, and then it provides us like the information to check on the status. And do client functions typically just follow this, or are there any other maybe best practices or things that are done here, or do we typically want to just kind of follow this format of like call the orchestrator, provide status, that's it?
So usually this initial client function shouldn't do more than just getting some input from somewhere. And since it's an HTTP one, that's very easy to provide some body and some content with it. So then your input for your orchestrator can come from the HTTP request message. But very often I don't use HTTP triggers, but I use, for instance, queue triggers or timer triggers for these things. So then the step before this will be maybe collecting some data from somewhere, or using an input binding here to maybe retrieve some table data or retrieve some blob data that will then be used as an input for the orchestrator. Okay,
awesome. So best practice, keep it minimal, I would say.
Yes, exactly. Okay. Yeah. The same is true for all these functions. They should be really short and concise and only have just one responsibility. That's good to
okay,
know.
Awesome. All right, let's move on to the orchestrator.
Right. Okay, so this is the orchestrator. So the only thing this function has is the orchestration trigger attribute. So again, Azure Functions knows, okay, this is an orchestrator trigger function, so I need to provide it a different context, in this case, the Drupal orchestration context. In the client function, we saw that we are passing in a transaction as an input, but we don't have the transaction here as an argument. And we only have the context, and we have a logger, and that's it. So we need to use the context to then retrieve that input. So there's a get input method on the context. So that's the way to retrieve an input out of the context of the orchestrator. So this will always be your first step. You can also start an orchestrator without any input, so that's also fine. You could also have an initial activity that retrieves some data, and based on that data, you continue. That's also fine.
Okay.
But in case you have provided an input, then you can use this. So then our first step is to get some customer data based on the bank account numbers in this transaction. So I've put this in a separate private method because I also like quite small methods, and if I put everything in this orchestrator, the orchestrator also gets pretty big. So sometimes I use this smaller private methods for these small dedicated tasks. So I'm also giving the Drupal context with this private method because it needs to call out to some activities now, and I'm also providing the input as arguments for this method. So now we see two calls here. We use the context to do a call activity async. So this will instruct durable functions to call out to an activity function. And we first define what type we expect back. So in this case, we expect back a customer type, and then we provide the name of the activity function, and we provide the input of the activity function. So in this case, I want to call the same activity twice. I'm calling this get customer activity twice, but once with the creditor bank account and once with the debtor bank account. Usually, you would do something like this, because this is an asynchronous call, and you probably want to await its result, and then this has the customer result in there.
Right.
And that's very useful when you want to do function chaining. So I first want to call function A, I want to wait till it's complete, and then I want to call function B and wait till it's complete, and so on. But in this case, I'm not awaiting them individually, because these calls can be called in parallel, because they're not dependent on one another. This syntax, I am creating now a task, but I'm not executing the task yet. So the execution of the task is done on this line. So I'm doing await task when all. So here the orchestrator is waiting when all these tasks are done. So when we arrive at this point, these two activities and the get customer activities will start running. This orchestrator will be idle. It won't do anything. But once both of these activities are complete, then the orchestrator will replay from the top of this orchestrator, and then it will continue, and then it will return the result of these two tasks.
Okay, great. So to summarize, the individual tasks, their order doesn't matter, but we do await to make sure that they're both completed before, say, providing a completed status, right? And
exactly.
and then that link that we used to check status and where it said pending, running, things like that, it depends on this return creditor task.result and debtor task.result, correct?
Yes, exactly. Yeah. So as long as activities are still at work, and then your orchestrator will still be in running state.
Okay.
But once all of the activities have been completed, then the orchestrator state is also completed. Yes.
Awesome.
And yeah, it is very important to realize that this orchestrator is going to be idle once it hits one of these activity calls. But once the activities are complete, this orchestrator will replay again, and it will always replay from the top. So once the customer data is completed, then this orchestrator will start again, and it will start again from the top. So it will again get the inputs from the context, and again it will try to run this function as well. But since the state of the workflow is kept, durable function knows that it already has performed these activity calls, so it won't execute them again. So it will simply retrieve the result, and then it will actually continue to the next part, and that's this.
Yeah, that's the beauty of durable. Like, you don't have to manage that. It knows, like, all right, I already did this. We're starting over again, but we don't have to do step one. We'll go on to the next one.
Yeah, exactly. Yeah, but I think when you're just starting and you've placed your debugger breakpoint there, then it might be very confusing, because you'll see these multiple executions of this orchestrator function. You might think, well, what's going on? Why is it running all these different times? But that's the whole purpose. That works as intended.
Okay.
Okay, so the next thing is not an activity, but I'm using a builder pattern to create one of these audit records. So I'm creating a new GUID. I'm passing in a transaction, and I'm passing in these two customer objects to create a new record. What you might notice that I'm not using the system GUID, new GUID method. I'm using something from the context, and that's also important to realize, and that has to also do with the replay behavior of this orchestrator. So this orchestrator needs to be deterministic. And that means that for every time this orchestrator will execute, it will always do the same thing. If I would use system GUID, new GUID here to create this audit record, that will create a new GUID every time this orchestrator is replaying. And that will result in different audit records. And
Right.
that will then mess up the rest of the orchestrator where this is used as an input for activities.
Okay.
So when you want to use GUIDs inside an orchestrator, it's fine, but you use the context then, because the context has a few of these helper methods and properties to create GUIDs for you in a deterministic way.
That's good to know. It's a good practice there. That I think that's something like you pick up with experience, because I feel like that's something like, if you're a beginner, it's pretty easy to stumble upon. Like, oh, why am I getting new records each time?
Exactly. Yeah, indeed. Yeah. Same as for datetime now, for instance. If you would use that, then you would get different datetime, different timestamps. So there's also a current UTC timestamp in this context as well.
Okay, so, awesome.
All right. So the next part, we're not calling out to the analyze part yet, but we are using something else in Dribble functions, and then those are called entity functions. So that's a more recent addition to Dribble functions. It's another function type, and instead of keeping the state of a workflow, for an entity function, it just keeps the state of that object. So in this case, there is, or I have defined an entity function, which is called fraud detection orchestrator entity. And the whole purpose of this entity is to capture the instance ID of this orchestrator. It's a bit technical, but this is required because at a certain moment we'll be waiting for the orchestrator for this fraud result to come back, right? For the let's say the approval event. So we will instruct the orchestrator to wait for an external event, and once that event is raised, then this orchestrator will continue. But you can only raise events against a specific orchestrator instance. So that means you need the orchestrator instance ID in order to be able to raise an event. But our fraud result that comes back from the analysis servers, that has no concept of Dribble functions and instance IDs. So we need to store this instance ID now in order to be able to retrieve it later, to raise the event in a proper way.
Okay. All right. That makes sense.
So entities works based on entity IDs, which are based on the name of the entity and then a key. And in this case, we are using the audit record ID as the key. And in this case, it's important that you use a key that's also known from the other side. So the fraud result will also have this audit record ID. Because based on that ID, we are able to match it up, and we can extract the instance ID from entities. So we've defined the entity ID, and then we will save the instance ID to this entity. And there are different ways of doing that, but one of the ways is called signaling. So that means I'm going to send a one-way signal, a one-way communication to this entity, and then you provide the entity ID, and then you provide the name of the method you're going to use. So again, everything is based on strings in this case, and you provide the value. So in this case, we want to set, you call the set method, and we provide the instance ID of this orchestrator. So at this moment, the instance ID is saved, and it can be reused once we get the result back from the analysis service.
All right, quick summary. Hold on.
Yeah,
we're using this this entity type. So when, like, let's make it like more general. Like, so when Durable goes out and does something, waits something from another service who has no idea, like that other third-party service, like, I don't care what you are. You made a call to me. I have this info. I'm sending it back to you. So in order for us to, so for that service to reference the correct one, we'll have to, save the correct instance, right? So we're using entity type entity functions for that. Okay, cool.
Yep. Exactly.
Got it.
Yeah. And entities can be used for to store all kinds of data. So in this case, we are storing something very specific for Dribble functions. But you can also use entities to store some game data or something, or to store whatever domain data you need. But in our case, it's very tightly coupled to Dribble functions and to orchestrators.
Okay.
All right. And so then it's time to call the activity that does the analysis of our audit record. So here we do an await and do the call activity. So in this case, we do want to wait for the results to come back. But as I mentioned, this analyze audit record activity, it's asynchronous, so it will only give back an accepted response, so it won't give back the fraud result immediately. So once we've done that, then we need to instruct the orchestrator to wait for an external event. Now we want to wait for that callback from the analysis service. So, but we also specify a timeout, because we could leave it out. We could just tell the orchestrator to wait, but then it will wait until eternity, right? It will wait until Azure Functions is completely decommissioned from Azure, which will hopefully never happen. So it's always good to provide this timeout and also a default result.
So that's a good practice, but not something that like will throw an error if it's not implemented.
No, exactly. No, because you can call it like this. So you can just wait for the event.
Okay.
And it's fine. It won't complain. But I think it's a bad practice.
Okay.
Yeah. So I
Good-
think
good to know.
you should always specify a certain timeout, and then it's maybe more or less a business decision. Okay, how long are we going to wait for a result to come in, and what will then be the default response to that? So those are more business decisions. In this case, I'm waiting for maximum 5 minutes, and I'm assuming that the default result, so my fraud suspicious transaction will be true.
Okay, and that's just sort of also like just a business decision, like just to be on the safe side, we'll think it's we'll say it's true.
Just to be safe. Yeah.
Exactly. Okay.
All right. So once the orchestrator hits this point, it will be idle again. So the state will still be running, but the orchestrator will not be active, because it will be waiting for an external event. Once the event has been raised in another function, we'll go to that shortly. Then the orchestrator will replay again from the top, and it will continue then on this line. And on this line, we will use the output of that external event, because we expect a type Boolean to come back. Events again are based on names, so we expect a certain event name here. So we update our audit record, and then based on if a suspicious transaction is detected, so only if that's true, then we will call yet again another activity to store the audit record in Consoles DB. So this is a very typical case of where you use some kind of business logic, or depending on the event that comes in, we might call an activity or not.
Okay.
All right. So this is the orchestrator. I think it's nice that we look at the other client now. So that client will then be triggered by the analysis service, and that will do the raising of the event. So let's go there. So again, that's an HTTP triggered function. Dealing with webhooks, that's the most likely option there. So the setup is mostly the same. So it's an HTTP triggered function. It will listen to a post. In this case, I've strongly typed it that I'm expecting a fraud result here. Again, we use the durable client attribute to instruct Azure Functions that we can use the durable client context here. And then you see that we are again defining this entity, because when we come in, we need to find the instance ID of the orchestrator we want to raise the event to. So we define the entity ID, and we're using the record ID that comes in from the fraud result. So we use something that we know in order to get something that we don't know.
Okay.
So we've defined the entity ID, and then we use the durable client to read an entity state. And we then define what the entity type is, and we provide the entity ID there. It could be the case that I've specified a record ID here and there's no entity for it. So that could be. So what we first need to do is make sure that the entity exists. So we first do a check from, okay, I've defined this entity ID with this record ID. Does it actually exist? And if it does exist, then we can extract the Orchestrator instance ID, and we can actually raise an event to a specific orchestrator. So, and that's done in this part. We use the client to raise an event. The first argument is then the Orchestrator instance ID. The second argument is the name of the event that we're raising. And then the last argument is then the Boolean result that they want to pass in.
Okay. And what kind of scenarios does this happen often, or where do you see this happening, where you get that an entity doesn't exist?
It doesn't happen often. Maybe something weird happened because we were talking to an external API, a third-party API out of our control. So maybe something goes wrong there, and it mangles up somehow the input that we send, and it maps it differently to some other input, and that might result in a mismatch of IDs on this side. And so that might be some kind of a mismatch that's happening here.
Okay, so if a third party is involved, could be on that end, but you don't really see it happening often, right?
I don't see it happening often, no. Another thing which might be trickier could be maybe some kind of weird timing events. So maybe that be also very extreme, but maybe this webhook gets triggered earlier than the entity state has been set.
Okay, yeah.
So for instance, I'm swapping back to the orchestrator now. Maybe if you could share
there we go.
Yeah. So we're now back in the orchestrator, and because now I am storing the entity first and then calling the analyze auto record activity.
Okay. So if the order was, say, wrong there, you could also say run into that error. Okay.
Exactly. So if I would do this first, and that third-party service responds really quickly and activates the webhook, and I haven't saved this yet, well, yeah, then again, I'm not finding it.
Okay.
So,
all right, that makes sense.
Sometimes the order of execution is really important, Anita. So that's good to know.
Okay. I did want to address, I know we have a couple of questions in the chat. Well, I'll try to get to them towards the end. I think we're maybe 5-ish, 10 minutes left.
But this is almost the end of it.
Yeah, we're almost done, so we'll get to those questions.
Webhook. So so what happens here is we raise the event to the orchestrator responds to it, and then does the last step. And what we only do here is we return an accepted result, and that's it. Or in case the entity does not exist, we send a bad request back to whoever is triggering this.
And this is an example of a different client function. It does a little bit more than the initial one that kicks off, I guess the initial kickoff. Then there's some validation we could say that's in here, but besides that, it still pretty much does the same as what the original client. It follows that same format, right? Exactly.
Yeah, indeed. You need to do something with an input indeed, usually in these clients, and you then interact with the orchestrator. And in this case, we're not starting an orchestrator, but we are interacting with an orchestrator, and that's the raise event part. The same type of steps are happening with these client functions. Yeah.
Right, and this specific client is the one that gets called by the third party, and you can have different. If you need your workflow, I guess, to be called by different places, with different inputs and things like that, you can have different client functions, different ways to get into to kick off the whole thing, right?
Oh, definitely, yes.
Okay.
Yeah.
Awesome. I think we stepped through everything. That was quite a lot, and even with some errors, we got through it in time. We do have some questions. Have some questions if you want to answer them. Let me scroll up first just so we go one by one. Justin, hey Justin, asks, hey, this is great, Gwyn and Mark. I'm new to serverless. Where should I start? I think we're both biased towards functions, but I'm curious to see what your answer would be, Mark.
Yes, yeah. Do you mean indeed Azure functions or serverless in general? Because we always assume also that serverless is only compute, but there's also databases and stuff like that.
That is correct.
Compute. But yeah, sticking to compute, maybe. Yeah, of course, I'm very biased because I think Azure Functions University is a good place to start.
Yes.
But I think we have quite good learning paths as well for serverless when it comes to functions.
Absolutely. To highlight that comment, you said that serverless is more than functions as a service. Functions as a service is probably the most popular when you think of Azure Functions, AWS, Lambda. Google, of course, has one. I can't remember the name at the moment. But yeah, there's like serverless and serverless databases, messaging, all those kind of good things. So maybe pick the area that you're most interested in, like if that's, I guess, code, or if that's, databases. Like I think whichever flavor of thing that you're interested in, there's some sort of serverless option for it, and get dip your toes into that way. And yeah, Microsoft Learn has a bunch of fantastic modules. And then if you're a fan of Azure Functions, check out Mark's Azure Functions University for sure. This is can you elaborate? I know you mentioned gaming, Mark. Can you elaborate a bit on the gaming use case?
Okay. I haven't been working in the gaming industry, to be honest, but for me, I think it was about durable entities. So whenever you need to store some state, then durable entities can be very useful for you. Some compare it to the actor model. So you can just define an object in C# just a class object with properties, and you can then quite easily reach out to these properties and check their state and manipulate them. So that's why I made the analogy to maybe you will have some game state you want to capture, like high scores or player information and things like that. That would be definitely suitable to store in durable entities as well.
Right, and remember that durable functions itself is it's a way of you defining some sort of workflow that needs to wait on different things, right? If you need to wait to retrieve some sort of like specific player data or like a game session, things like that, that's how like this, I guess, model would work for something like that.
Exactly, yeah. You could indeed use durable functions as well as part of some kind of game engine, for instance. That would be possible.
Yeah. Here's another one. Would any of the setup structure in the demo be any different if we were coding in JavaScript?
Not so much, to be honest. No, because you can do everything locally as I was doing now. As you would need Azure for the storage emulator part, Cosmos DB emulator, it's also cross-platform. So the language difference, it's in JavaScript or TypeScript you can do exactly the same as with C# when it comes to durable functions.
Absolutely.
So you could completely rebuild the whole thing in JavaScript. That would be amazing. If someone wants to help me and create
that would be awesome.
the content for JavaScript for this, that would be awesome.
Yeah, the actual having client functions, activity functions, orchestrator, entity, all of that exists in no matter what language you're using, as long as it is supported by functions. The only thing that changes is the actual syntax of the language, right?
Yes. Exactly. Yeah, indeed. Yeah.
All right, I think we've tackled all these questions, and we're right at the 1 hour mark. I want a huge thank you for joining me on this session. I'm sure we'll have more things planned out for the future, and maybe we'll tackle different topics and such. But this was great.
This was fun.
I had a good time. We had some errors, but we figured it out. And thank you to the chat for hanging out and asking all these questions.
Yeah, thanks everyone.
Thank you, everyone. So I'm going to do a quick plug here at the end, just to let you know when we'll be back again next week, next Wednesday, same time, same place, and continuing on with this series. So if you have the opportunity to check it out, definitely come back for more. And her sessions will also be on demand if you miss it. You shouldn't. You should be there. But if you do,
of course,
you can watch them.
Yeah, and I dropped into the chat a survey. We are always looking for feedback, what kind of topics you, the audience, are interested in. We definitely want to appease to your needs where we can, as far as it's technical related. So definitely let us know, fill it out, get back to us. And then again, if you're not part of the Reactor community, you should be. We always have content coming out. We're an international program. We have 11 physical spaces as well as a virtual world right now where we're always running content. So definitely, if you don't know about us, you should check us out on Twitter, go to our website, microsoftreactor.com, find us on Meetup. We're everywhere. So thanks again, everyone. And thanks, Mark. Thanks, Gwyn. This was fantastic.
Awesome. Thank you.
Great. Bye-bye.
Bye-bye.